Hello, everyone. Welcome to Lecture 6 of Comp 150. So the plan for today, we'll have two small topics. One will be matrices and one will be strings and operations on strings. So let me tell you what matrices are. So far when we talked about lists, we talked about only one-dimensional lists, but sometimes you may have two-dimensional lists, for example, representing, I don't know, maybe colors in a picture, or maybe you can have a three-dimensional list, for example, representing temperature in a room. So today we'll talk about two-dimensional lists. So here is how I represent two-dimensional lists in Python. So basically, a two-dimensional list is represented as list. So these are the outer brackets. And inside each row contains a separate list. Okay, so you can think of this matrix 1 as really, this is what we're trying to represent. Okay, so look at only these 3 lines, 4 lines, right? Or how many lines we have here. Let me try to only run code for this part. So here we're creating this matrix. So here is the matrix, just list that each entry is a list inside. And, we can print it. Oh, no. Let me try it again. We can print this line, and it prints, opens the opening brackets, then it prints the first element, which is a list itself, then the second element, then the third element. Okay. How do we access a particular entry in the matrix? Well, the way we do it is we write first the name of the row, right? The index of the row, so row 1, and then the index of the column. So for example, here, matrix 1, 2, we go to row 1 and entry 2. So it should print 6, and indeed it prints 6 here. Okay. So here is what I want to do next. This representation is sort of not very nice, right? It's not very easy to see that it's a matrix. So instead, what I would like to do, I wrote this function called print matrix. So I'll do step into F7, and I'm going to print each row in a separate line. So how do I do that? I say for each row in M is the argument that we get, print the row. So we'll print the first row, and then the second row, and then the third row. This is a much nicer representation of our matrix. Okay, so we'll have a function called print matrix, that what this function does, it prints the matrix row by row. Okay, that's much nicer. All right. Okay, so that was this line. So let me define another matrix, matrix 2. So it will have 2 rows, and again, 3 columns in each row. And here is what I want to do next. I would like to ask, what does this thing do? So remember, when we had 2 lists, we simply concatenate the 2 lists. For matrices, it will be exactly the same. We concatenate the 2 matrices. Namely, we take, this was our first matrix. This is our this is our first list. This is our second list. What do? We just concatenate them. So let me print. So I'm going to print m concat is equal to maybe I should not do this end of line, and so I'll run it again. So here is what it prints at the end. It prints, well, the entire concatenation, right? So it concatenates the first part with the second part. So this m concat has 5 elements in the list, 5 rows, and these are the 5 rows. Okay. So basically, a matrix is just a list where each entry inside is a row of this matrix. Okay. I hope this is helpful. All right. And here is what I want to do next. I want to try a couple of operations on the list. Okay, so we'll start with this matrix. And okay, so we saw how to print it. So I'm going to remove this because this has already appeared before. So here's what I would like to do next. I would like to create a matrix consisting of all zeros, for example. And let's say the height will be 4 and the width will be 6. And here is what I will do. So and I'll have this the print function. Okay. I define height and width. I define one row. So you remember, when I want to create a list, I can create it by using this multiplication operation, right? So I start with 1 0 and I defined with many zeros. So a row will simply consist of 6 zeros. And then my matrix will be, well, I put row in brackets, and which means I get a list of that contains one row, and then I multiply it by the height. And when I print the matrix, what does it give me? It gives me a row of zeros. It gives me a matrix consisting of 4 by 6 of zeros. Is this the correct way to create a matrix? I would like to say no. So here is the problem. Let me modify the 0th entry to be 1. So I modify only this top left entry to be 1, but when I print it again, here is what happens. Let me separate it with this. And when I print it again, it modified not only the first row, but it modified all the rows. The reason for that is that it actually put the same row in all the entries of my matrix. Okay, so it didn't make copies, but rather it put the same row in each entry of my matrix. So this is incorrect way to do it. Okay, so instead let's do it in the correct way. Let me comment this out. And for example, one way to do it will be to say my matrix is in the beginning the empty matrix, and then I will say for I in range height, I would like to say my matrix append. So remember the append operation that adds the next item. And what will I do in append? I will multiply this by width, 0 by width. Let's try it now. When I run it now, it changed only the one entry that I wanted, and it didn't change all the others. So let me add a comment here. Incorrect, because it will use the same row for all lines of the matrix. Or in other words, each line of the matrix will point to the same row. Okay, so this is the correct way to do it, okay, or one correct way to do it. Okay, so this was my matrix operation 1. So what we did now is we created a matrix of all zeros, and then we could modify some of the entries. All right, and we still have this print function. All right, that's another example. So let's see our third example. I still have the print matrix function. All right. And here is two exercises that I would like to do. So I'm going to create my matrix. I'm going to print the matrix. I'm printing the matrix, and here is what I want. So my matrix is, this is my matrix, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. I would like a function. So here is an example that computes the sum in each column. For example, here it's 1 plus 4 plus 7, that's 12. 2 plus 5 plus 8, that's 15. And 3 plus 6 plus 8, that's 18. Okay. And I would like another function that will compute the sum in each row. So in the first row, the sum is 6. Here is 6. In the second row, the sum is 4 plus 6, that's 10, plus 10 plus 5, it's 15. And in the last line, 7, 8, 9, together, that's 24. Okay, so how will we do that? Okay, so you can pause for a second and think how you would compute the sum of columns. Oh, so this should be sum of columns and not sum or columns. Sorry about it. Okay, so let's see how we compute sum of columns. Or maybe sum of rows first. Okay, so sum of rows is kind of easy. So we'll create a list called result. And for each row, what we will do is we'll append to the result the sum of the ith row, right? So we take the first row, we compute the sum. So remember, sum is a standard function in Python. We compute the sum of the first row and we append it to result. Compute the sum of the second row, append it to the result. Compute the sum of the third row, append it to the result. This is it. This is very simple, right? Right, if we want, we can break it into maybe sum I is equal to, and then, right, so this will give just a number. Okay, so let's try to run this function. Okay, let's see. So our matrix is 1, 2, 3. So the first row is, or the 0th row is 1, 2, 3. When we compute the sum, it gives us 6. We append it to the result, right? So the result now is 6. Result here is 6. Next, we compute, next row is 4, 5, 6. We compute the sum, that's 15. We append the sum. So we add 15 here. The next row is 7, 8, 9. We compute the sum, 24. We append it to the sum, right, to the result. And then we return the result, and then we print the result. All right, so that was kind of easy. Let me modify back to this. All right, what about sum of columns? So here's the thing. Although for columns, you would expect something similar, but it's really asymmetric, right? Because each row is one entry in our, well, in our matrix is you know, each row of the matrix is one entry in the list representing it, but the columns are not. So what we'll need to do, yeah, we'll actually need to have two for loops. Okay, so we'll have, so we'll first compute the height of the list. It's, so what's the height of the list? It's how many L of the matrix, sorry. So this is equal to the length of the list representing the matrix. Right, so we'll have a result, in the end we'll return it. How do we know what's the width? So the width is just the length of the first row, or width of any row. Okay, so here's what we do. We'll go column by column. So I will go over the range of, you know, from 0 up to width -1. Si, let me call it sum I, will compute the sum. We'll start from 0, and then we'll loop over all rows of the matrix, and we add to sum I. What are we adding? The matrix in position ji. So j is the jth row, and I is fixed, right? I is the column that we're looking at. So after we computed it, we'll append the result. We'll append the sum to our result. Right, so just to clarify, go over all rows and add to the accumulating sum. Right, so sum I, so this is the sum in the ith column. Okay. Okay, and this is how we compute the sum of columns. Okay, so sum of rows and sum of columns, although it looks very similar, but there is something not symmetric there because of how matrices are represented in the in Python, right? So the matrices are presented as list of rows, so each row is easy to access, but each column is not. Okay, so we need to access them actually entry by entry. Okay. So that's our second example, right? So we compute sum of rows and we compute sum of columns. All right, and let's try one more example. So here's what I want to do here. So I create my matrix. Let me try to run it, and then we'll see what exactly we're doing. Okay, I'm creating my matrix and I'm printing it. Then here's what I want to do. I want to multiply all entries by a scalar. So scalar means just multiplying it by a number. For example, this was our matrix before. And after I multiply it, the matrix becomes, well, you see all entries were multiplied by 3. So it was 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it's 3, 6, 9. Each entry is multiplied by 3. So I want to write this function. Okay, so that's the first thing I want to do. Okay, so creating zeros is something we did in the previous exercise, but sure, let's create the matrix of zeros. So we'll remember again how to do it. And then we'll have a function called add two matrices. So it gets two matrices and it adds them together. So what do I mean? For example, if I take a matrix and a matrix, so I have a first one that's 3, 6, 9, 12, 15, 18, and so on. And I have the second one that's exactly the same. The sum will be just pointwise addition of this. So I take this matrix and I add it to itself, and I get just entry-wise, I multiply it. And the assumption, maybe I should change this. Let me call it maybe matrix 1. Maybe I'll make a smaller matrix that's a bit easier to see. And I'll make matrix 2 that will be maybe 0, 5. Oh, you know what? I'll even give it a nice representation. Maybe it will be -2, and here it will be 3, and here it will be, I don't know, 1 and 1. And I will want to add matrix 1 to matrix 2. So what will be the result? So the result will be msum will be the following. Let's see, 1 plus 0, that's 1. 2 plus 5, that's 7. Then 4, 6, -2, 3, that's 2 and 9. And the next row is 8 plus 1 is 9. And 9 plus 1, this 9 plus 1 is 10. Okay. And we'll print this. Okay, so let's see first how to multiply a matrix by a scalar. So how do we multiply by a scalar? Well, it's pretty straightforward, right? We'll have a nested loop. So we'll go over all rows. In the ith row, go over all columns. And then multiply by this number x that we want to multiply. Right? Multiply the entry mij by x. That's how you do it. And how do you add two matrices? So to add two matrices, we want to create a new matrix. So here's what we do. Remember, previously we did this function called, we created this function called create matrix of zeros. And here is how we did it. We said, oh, we'll have the result. This is what we return. And we go over, right? We create height many times. We append a row of zeros to our result. And notice here that there's no need for an index I, so I put an underscore here because it's the name of the variable is not important. Okay, so here I'm creating a matrix of 0. So remember, this will be the height, and this will be the width. And then I'm going over all rows. In the ith row, I'm going over all columns. And here I'm adding, well, it's kind of clear what's going on. I'm taking the first matrix in position ij, the second matrix in position ij, I add them up, and I put it into the result. And it's important to have this assumption that M1 and M2 have the same dimensions. If they don't have the same dimensions, then kind of matrix addition doesn't make sense. Okay, so this is how you add two matrices. Right, so if this is my first matrix and this is the second matrix, then their summation is just entry-wise addition. Okay, 1 plus 0, that's 1. 2 plus 5, that's 7. 4 plus negative 2, that's 2, and so on. Let's try to run this. Indeed, it gives the result as we expected. Okay, so what did we learn here? So what we learned here is how to do operations on matrices, how to add two matrices, how to multiply a matrix by a scalar, how to create a new matrix. And let me give you a couple of exercises. So here is one exercise. Write a function that gets a 2D matrix and returns a list that in the ith index contains the maximum of the ith row. So what do I mean by this? Let me change it to column. So, sorry, it should be column. So for example, if this is my matrix, then the maximum in the 0th column is 4, the maximum in the first column is 9, the maximum in this column is 7, here is 7, the maximum in this column is 9. Write a function that gets a matrix and returns the maximum in each column. Here's another example. Write a function that gets a matrix again. It's a 2D matrix and returns the sum of all entries in the matrix. Here is another example. Write a function that gets a matrix and changes all negative entries to zeros. That's another example. Okay, here is another example. Write a function that gets a matrix and changes all positive entries to their negatives and all negatives to their positives. For example, if this is our input, the negative 1 is changed to 1, the 2 is changed to negative 2, 3 is changed to negative 3. For example, negative 9 is changed to positive 9, 0 stays 0. Here is one more example. Write a function that gets a number n and returns an n by n matrix with this pattern. So 0, and then there's 1s and 2s and 3s on the diagonal. Next diagonal is 4, next diagonal is 5, and next diagonal is 6. How about I give you one more? Here is one more practice problem. So this will be number 6, I suppose. It gets a matrix and transposes it. This means if the matrix was n by m, then, oh no, and returns a new matrix, get a matrix m, and returns a new matrix that is the transpose of m. For example, this means if m was n by n, then the result is m by n matrix. And all the entries are sort of, and for example, if this is the input, then the function returns the following. So what it returns, it will return, okay, let me make it a smaller. Okay, 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11. All right, so let's say this is our something went wrong here. What it will return will be the following. It will return, so the rows become the columns and the columns become the rows. 3, 4. Sorry. 5 and 9. And here we'll have 6, and then 7, and then 8, 10, 11, 12. So it gets a matrix and it turns the rows into columns and columns into rows. So it returns a new matrix, right? So I will emphasize it's a new matrix. That the rows are where the rows are the columns and the columns are the rows. So this is our examples about matrices. So that was one topic. And the other topic I wanted to talk about today is string operations. Okay. So we talked about strings, but I will add sort of more and more operations on strings. Okay, let's do string operation. Let me close everything and we'll do string operations. Let's start with a simple one. So in is the same as operation on lists. Basically, if we think of string as just a list of letters. So if we take the letter A and we ask, is A in fruit? Yes, A appears in fruit. Right? So A appears here, here, and there. So the word fruit, so if it's in fruit, it will say yes. Yeah, and we'll print, yes, indeed, the word banana contains the letter A. But strings can do, in fact, more. Even if we take a substring NA, so NA also appears in banana. So it will say again, yes. Right? So in for list, for strings corresponds to having a substring. But for example, NAA, that banana doesn't contain NAA. So it will say, no, it doesn't. And we can do count operations, just like we have in this. So we can count how many A's we have in banana. And A appears 3 times in banana. And we already saw these operations, right? So plus corresponds to concatenating strings, just like concatenating lists. And if we have this yay multiplied by 3, it will multiply yay 3 times, right? So we'll print yay, yay, yay. Okay, so these are pretty standard. We saw these ones already. Good. Let's try example 2. Example 2 is compare strings. So I'd like to write a function, or rather not write a function, just to see how we compare strings. So I wrote this simple function called compare strings. It gets 2 strings, and it says if they're equal, it says strings are equal. If string 1 is less than string 2, it says string 1 comes before string 2, and otherwise it says string 1 comes after string 2. And let's try it for each of these examples. Okay, so we run it on different comparisons. I don't know, maybe we'll also add some like XYZ and XYZ. Okay, so XYZ is equal to XYZ, that's clear. How do we compare ABC and XYZ? So the way strings are compared are letter by letter. Okay, meaning if they compare the first letter, so if A comes before X, it means that this string comes before this string. So we compare them in alphabetic order. So A comes before X, so it just stops there and it says A comes before X. ABC comes before XYZ. ABC comes before ABB. Why is that? Well, A is equal to A, B is equal to B, but C comes after B, which means C comes after B, which means the string comes after that string. Okay. Why does ABC come before AX? Well, A is equal to A, but B is less than X, which means, what does it mean? It means that this string comes before this string. What about ABC compared to AB? A is equal to A, B is equal to B. Here we have another letter C, and here we don't have anything. Oh, in this case, it means that this string comes before. So they come in alphabetic order, but if one string is prefix of the other, so the prefix comes before the longer string. And of course, apple comes before banana because apple starts with A and banana starts with B. Okay. Okay. So how about, here's what we'll do. Let's try to write a function called str compare that gets string 1, string 2, and returns, I don't know, 0 if the strings are equal, returns -1 if str1 is before str2, and returns 1 if str is greater than. Okay, here's what we do. So let's call it, I don't know, n1 is equal to length of str1. N2 will be the length of str2. So frankly, I haven't prepared it, so I'm kind of doing it on the fly, but we'll see. Okay, and I want the minimum length. So I want the minimum length to be equal minimum between n1 and n2. And I'll do the following. For I in range min, okay, so what do we do for I in range min? If str1 in position 1 is less than str1, 2 in, sorry, in position I, what does it mean? It means that the first letter, the letter in the first string is smaller than the letter in the second string. We'll just return -1. If it's greater, we'll return 1. If not, we continue and continue and continue until we reach the end of the longer string. Sorry, of the shorter string. Okay. And now here's what we do. If n1 is equal to n2, we return 0, right? The strings are equal. Found, okay, let me do some comments. First letter where and we'll do the same thing here. Found first letter where str1 is greater than str2. Okay. Remember our elif. If n1 is smaller than n2, that means that str1 is a prefix of str2. So in this case, we return -1, right? So str1 comes first. And otherwise, return 1. str2 is a prefix of str1. str2 comes first. All right. So this is our code for comparing two strings. Okay, so we compute the lengths of them. And then we go letter by letter. But, you know, we don't want to, if the strings have different length, we want to only go up to the length of the shorter of the strings. If we found a letter that they're not equal, check if we see some index I where the letters differ. If we found such a thing, then we return either -1 or +1, depending on whether the letter is greater or smaller. And if we reached the end of the shorter string, then we should see if the strings are equal length or one of them is prefix of the other. Check if the strings have equal lengths or one is the prefix of the other. Okay, so I did it very, right, super explicitly. Namely, I didn't use almost any functions, well, except for computing the length, I didn't use any functions, right? I actually compared it letter by letter. All right. And here I forgot this column. Okay, so that's how we compare two strings manually, right? So we wrote our own function. Let's write our own function for comparing strings. Right. Here is more string operations. Okay, we'll start with some text, like hello world. And I would like to show you just a bunch of functions that Python has. For example, ends with. So hello world ends with LD exclamation mark. So if we check, does it end with this? It will say yes. So yeah, it will say text ends with this string. Does it start with HE, with capital HE? Yes, it does. We can convert text into lowercase. So when we do lower, it returns a new string that it's a lowercase of that function. Sorry, of that string here. Now it's all lower cases. So here is text2. Hi, I'm Bob. But it has sort of spaces in the beginning and spaces at the end. So what strip does, it removes all the spaces. So now you see there's no spaces in this. So after cleanup, it's just hi Bob with no spaces, right? So here we did have spaces, here we don't. We can remove only spaces on the left or only spaces on the right. So here is after cleanup L, we take the same string text2, right? This hi Bob. It removed the spaces on the left. Right, and we can remove the spaces on the right. So here the spaces are left on right on the left, here the spaces on the right, but we remove them on the other side. Oh yeah, and here's another super nice operation. So let's say we have a sentence that we put in one string and want to split them into tokens. So tokens are, in this case, words of the sentence. So they are separated by spaces. So when we write print, so the tokens are a list. So this tokens, it's a list where each entry contains one string, one word from this from the sentence. And in the next example, we'll see an exercise related to this. Okay, let's see. So here's what I want to do in this exercise. I would like to start with, please ignore this thing at the end, only these 3 lines. So here's what I want. I print S, and then I say T is reverse sentence. So reverse sentence means I take all strings and I put them in the reverse order. And I'll have a function that gets the string S and returns the string in the reverse order. Let's see how we do it. So here is our reverse sentence. So we first split the text into tokens. So here, the tokens, we have all these tokens. Result is what we will return in the end. And I will do it here with the while loop. So I will go over the words one by one in the reverse order. And I will, here's what I do, right? I start with I equals length minus 1. And I say as long as it's greater or equals 0, append the ith word, append the word operations, right? So result becomes operations, and then append the space. And then go with I go one index, right? Subtract 1 from it. Now tokens in position, now I is 4, which means we're a string, right? This word string. I add string, I add space, and then I subtract 1 from index. Now we add about, I add space, subtract 1, and so on. We add the words one by one. We get to we added the space at the end. We're almost done, except there's this space at the very end. So what I'll do, I'll use strip to remove the last space, and then I return the result, and then it prints the result. So in fact, in the previous example, we saw that we don't need to do, we can in fact do R strip, right? Which means strip on the right. Let's try it again. Yeah, this also works. Let's see that it doesn't print anything unnecessary. So in quotation marks, right? So there's no unneeded spaces. You can ask yourselves, well, how do I know all these operations? So basically, you can go to this website, Python strings, and it will teach you a bunch of strings. Or you can use this function called dir. And the function dir, what it does, it prints all possible operations for a string. So for example, is it alphanumeric? Does the string consist only of numbers and letters? Is it alpha? Is it decimal? Is it a digit? Is it lowercase? Probably there is here somewhere, here is our R strip that we know. Just like we have lower, there is upper, and there is all bunch of other operations. So if you go to this website, then you will find a bunch of useful functions here. Oh, where do I find all these functions here? Oh yeah, you can find something like how to access a particular entry, how to slice a string. Here we talked about slicing in one of the previous lectures. We can talk about, oh, this is already lists. This is not strings. Anyway, sorry, I should have looked at it before doing it. But basically, this website should contain a bunch of different operations on strings. Another way I like to do it is when I do debugging, to know what exists is, or not what to do debugging. I can write, for example, s dot, and then it gives me a list of all these different functions. For example, if I want to find, I don't know, index of the letter A, so when I run it, it will print 3. What's 3? 3 is the first index that contains the letter A. Okay, so you can sort of look up different functions that you think are useful. Or for example, as capitalize, if we print it, what will happen? Oh, if it was lowercase, I think it will capitalize it. Yeah, it was lowercase before, so it capitalizes. Or if you can write upper, it will turn all letters into uppercase. Yeah, and so on. All right. That's all for today. Thank you all.